It's time to bring the power. By the time we're done here, we will ensure all CCNA lab devices are online, accessible, with the correct interfaces identified. And after going through the videos in this skill, we have a little bit of work to do in terms of identifying exactly what interfaces we have. Now, in a previous skill, we built the network diagram using our best guess. And I know just because we did a couple commands on those devices, I'm like, we're a little bit off. So I'm going to take you back to the CCNA lab topology from a high-level perspective. We have Arizona as the headquarters office. We've got a nice little pod of equipment there. Nevada and Florida as the remote offices that are getting their internet and network access through the Arizona headquarters. If we go a little deeper into the topology, this is what Arizona looks like, as well as Nevada and Florida. So let's hit our objectives for this lab. First off, I want to ensure that all devices are connected based on the copper and fiber cabling lab. They're all powered on and they're accessible from the console port and have a blank configuration. I want to make sure everything is completely erased. My main reason for doing that is we took a pretty heavy sledgehammer to our pod when we were going through and talking about the console board. Everything's kind of disconnected. I just want to go through and verify everything is here. From there, we're going to verify all ports on all devices are accurate, as in fix the network diagram. I know just from doing the show IP interface brief command in a previous nugget, that interface and that interface are completely wrong because it was using the three-level modular syntax, the syntax that looks like this when it's referring to those interfaces. So I want to make sure that is all accurate. And as a bonus, we want to go through and set the host name of each device. Now, on this one, I have them labeled as Access 1, Core 1, Core 2, but I don't think that's the naming convention that we're going to land on. I'm going to show you a little bit about how to name your devices well when we get there. Now, as before, if this is your first time going through this, you're not too sure what to expect or even what to do, how to approach it, then just go through, grab a notepad and take some notes as you're watching me go through this lab, listen, learn, conquer it, right? If you have any idea what to do, and I'm not talking like, man, I feel like a superstar, I'm ready to go. I'm like, I know how to get started. Then I want you to pause this and go through this exercise for all of your own equipment or emulated environment, depending on what you chose to build. The reason I say that is that's where the deep learning happens. Just this morning, I'm looking outside. I was sitting on, we have a little rocking chair out front on the porch, and I was sitting there, and my son came out, followed by my wife. She goes, "Wow, we need to blow these leaves off. It's starting to become fall here in Arizona." And I go, "Josiah, you feel like learning how to use a leaf blower?" And he's like, just had that look of like, okay. And I said, let's do it. And so I put it in his hand, powered it on, and before long, he's blowing the whole house. And I'm like, he's got it. He wouldn't have done that if he would have just watched me. He's watched me 1,000 times. He's never done it himself. So that's the kind of deep learning I want you to get, not with a leaf blower, with Cisco devices. So if you're going to pause right here, okay? Let's work through this. All right, here we are. It's a mess, and I'm going to clean this up. You don't need to watch every single bit of this, so I'm going to put this on hyperspeed. The only thing that I will say is you want to go out and grab a couple of these. I got them from Monoprice. These are Velcro wire ties. Look like this when it's said and done, to make it just look good. A lot of people, and myself included, I used to think, well, it doesn't really matter what it looks like. It's, functionality is there. And I've learned from being in the field forever that a messy rack really means a messy network. It's kind of like, if you really want to know somebody, look in the trunk of their car. Are they really a clean person, or are they just putting on a front? Same thing. Is it really a well-designed network? Is it really something that follows standard, that has change control, et cetera, et cetera, et cetera, all stuff that you'll be learning? Show me your rack. Because if your rack is a spaghetti mess, I could probably tell you what kind of network you have. So that being said, let's go. So this is it. Our CCNA pod is cabled and powered. I don't have that nice quiet room anymore. Everything is cable managed. And I know some of you might be like, it's a bit extreme for a lab environment. I'm telling you, just like I said before, if you're not neat with your cables, it just starts becoming a mess. And people are, well, what if I have to trace a cable? Why would you have to trace a cable? You've got the network diagram where we're going to be updating all of the ports and what's connected to what, right? That's another phase of this lab. So it shouldn't be that we have to trace cables and figure out what's where. Now, I'm not telling you, if you're early on in your lab, you like plugging and moving things around, then obviously that's not the time to wire tie it and lock it down. But I'm saying we're building this pod just like a real network, so the stuff shouldn't move around a whole bunch once you've got it all cabled. Someone else might be thinking, what about under the desk? You didn't show me under the desk. Well, you ever see in racks where they have the little cable managers, or I should say the wire manager? What is it? The thing with the little teeth, whatever it's called, cable organizers. You have a cover for those because there's some places you just let it be spaghetti. And since I don't have any cable management here, that's my under the desk. So you won't see under the desk, right? Just let everything drop there. Keep it nice and clean up here. I think we're ready to go. So I'm going to bring it back to our objectives. We now have everything connected and everything powered on. It's like a half check mark right there because I haven't ensured they're all accessible from the console port and ensured they all have a blank configuration. Now, there is one catch to all of this. If you encounter a device that has an existing configuration, you're probably going to have to do password recovery unless you know the password to get in that device and erase it. I'm going to create a special skill just on doing password recovery because it's not for everybody. You don't need to do it all the time. However, having a handy reference when you do need to do password recovery, worth its weight in gold. So that'll be another thing. I'm going to go through and ensure all these devices are accessible, configurations are erased if necessary, and bring it back here in a second. All right, so I'm back here again, plugged into the Cisco 1921 via console port, got the PuTTY terminal up on the screen. Only thing I want to show you before we really get going is just how to clear the configuration off on one of these things if you have the password. Again, password recovery will be a whole nother skill, but I'm going to go into privilege mode, that's enable. Fastest way to do it is to type in write erase. And that says I'm going to erase the NVRAM. That's the non-volatile RAM, essentially where it stores the configuration. It's still there because it keeps the configuration in memory. We'll do a reload, hit enter, and by the time this thing boots up, it's going to be asking for initial configuration dialog one more time. So I'm going to do that same exact thing on all these devices in hyperspeed. Awesome. All the configurations are cleared. I'm watching them reboot on the screen right now. You can see one of the switches going at it right here. So let's look at our next objective. All right, I feel comfortable putting the rest of that checkbox on there. All the devices are accessible from the console port. They all have a blank configuration. Now let's verify that the ports on all devices are accurate, as in fix our network diagram, because I know some of this stuff isn't accurate, especially when I look right there, 1 and 2, because I didn't know what those were. I took my best guess here. So let's jump over. This is the Cisco 1921 that's in the Arizona pod. That's this guy right here. I'm going to move my console port back over to him. And let's see what interfaces he has going on. He's sitting at the would you like to enter initial configuration dialog. I'm going to hit no. Hit the enter key a couple times. Now, it pops up with this name of AZHQ router. We're like, well, I thought we erased the config. Well, since this guy, watch this. I'm going to go into privilege mode and type in that magical command, show IP interface brief. Since this guy got his address via DHCP, the DHCP server actually learns and assigns a host name to him. Since we set it to AZHQ router before, the DHCP server actually learned that, they communicated, and it reassigned it. So all the other configuration is actually blank. But right here I see Gigabit Ethernet 0/0 and 0/1. That's accurate looking back at our diagram. 0/0 connects to the internet, 0/1 to the Metro E. And I know because we wire managed it that the red 0/0 down here goes right here. This is our emulated internet coming in from the outside. The blue 0/1 goes right up here to our emulated Metro E switch, right? These are where we go a little wrong here. We've got fast Ethernet 0/0/0 and fast Ethernet 0/0/1. that represents these guys right here. This is 0/0/0, 0/0/1. That's what I need to fix on our diagram. So I'm going to come back here and write it in red pen. I'll clean all this up and make a final version at the very end. So we've got these two interfaces, which is actually accurate, except for now we know they are gigabit 0/1, and that letter is going to play a key role here. Gigabit 0/0 and 0/1. I said that wrong. Then over here, this is where the ports are just completely wrong, because once we got in there, we found out this was fast Ethernet 0/0/0. This one right here was actually fast Ethernet 0/0/1, right? This is the process of creating an accurate network diagram. So now I'm ready to go onto those switches, Core 1 and Core 2. Let's head over there. I need to get my label in here. Actually, I'm going to do that right now so we save any confusion. All right, I got them. Standard network engineer toolset, scissors, and P-tape, P-touch. I know it's got a cutter, but I'm cheap. And when you print it, one name per label, it puts like 5 miles of extra blank around it because they want to sell you tape. Big scam. But this is actually a great time to talk about the host name of each device. So yeah, we're going to do step 3. Yes. We're going to do step 3 and fix our network diagram, but we might as well name them as we go. Now, there is a whole ton of stuff that we could talk about on naming convention. As a matter of fact, if you go into, if you want to know a bunch about it, go to IT Expert Switching. I created a whole series on real-world configuring switching, and I did a whole video, like 15-20 minutes, just on naming conventions that you could use. I'm going to sum that up in like 10 seconds right now. You could go many different ways. One is insane, where you just pick fun names, like that's the Neo router, that's the Morpheus switch. We're not going to do that. You could swing the other way, where you're like, I'm going to have a name like this long, where every character means something, and there's a dictionary, a white paper that is written up that defines exactly how that's going to be. A lot of enterprises do that, which in my opinion defeats the purpose completely, because the point of the name is you access the device, you look at the name, you go, oh, I know exactly what that is, without needing a dictionary to reference. If you want to reference a dictionary, then you'll have network diagrams and everything. Anyway, I'm on a soapbox. So let me bring it right back to the middle where we're going to stand. I love just being simple with the name, but logical. Location and device. So if I was in Arizona right here, I would probably, if these were all in the same room, I don't, so let me just, I'm done. So I will name these location, so AZ dash, and if I have multiple rooms in the facility, I might do like MDF or IDF or IDF1, IDF2, all those kind of things. But since I'm assuming this is all one room, fairly small environment, that's where I'll just put the device type. Again, 2-character representation. So we'll do a router is RT, a switch is SW, a wireless access point we'll just put as WP, right? So we can have AZ-RT01. That'd be this guy right here. That's the router. There's only one router, and that's fine. This one would be AZ-SW01, right? This one, AZ-SW02. Now, you might be thinking, well, it's Core 1, Core 2, Access 1. Well, yeah, these are names that I had on here when we were learning about network architecture and how it should be. I wouldn't actually name them that unless I had a really big network. So switch 1, switch 2, and then that access switch, that'll be a good switch 3. Will work really well. So, got the P-touch labeler. I'm going to print some labels out, stick them on there, because that'll save a lot of confusion moving forward. And print. Got our tape coming out. Oh, good grief. Obviously, my kids have been playing with this. I got a fancy border going around this whole thing. Well, that's what scissors are for. Lop it off, and let's stick it on the devices. Good. RT01. Sometimes it's hard to find a spot to stick these. I'm just going to kind of stick it over here on the left-hand side, cover some lights. Not best practice, but that's all right. Switch 1, switch 3, WAP 1, WAP 2. There we go. Got all our devices cleanly labeled so we can reference them in the future. And now I can move my console port down to switch number 1 so that I'm able to verify all the ports on there. All right, we're plugged in. I'm gonna click back over to my terminal here, hit the enter key a couple times. I'm sitting on the switch. I'll do a show IP interface brief. Ooh, look at that. We've got the interfaces being identified as fast Ethernet 2/0/1, 2/0/2, and so on and so forth. Now, you can tell this is this switch number 1 right here because I've only got 2 cables plugged in. They're both lit, and look at this output. This is the beauty of the show IP interface brief command. It shows the status of both of those interfaces is up. That's how I can tell, at least making a brief physical connection there, which switch I'm actually using. Now, why did it do 2 there? Well, at some point, this switch was probably in a stack. Those switches down at the bottom support something called Cisco StackWise, which is where the switch can combine itself with other switches. It's called linking the backplane, to where the 2 switches will act as one. Then they reference each other by switch number. So you can manage all the switches that you connect with StackWise from one place just by typing in, I want switch 1, I want switch 2. So that's what's happening right here in this fast Ethernet 2/0/1, 2. So this must have been in stack at some point. Now, it's not anymore, and that's one of the things I want you to catch is when I use StackWise, it's a one-time thing. It's once I connect them, it's identified those interfaces, and now it's staying like that forever, even though it's not in a stack anymore. But I need to know how I reference them. Do you understand why when I started the whole identifying the interfaces video, I was like, I don't know what these interfaces are. That's why that show IP interface brief command is so important. Now I'm going to scroll down all the way to the bottom because I want to know what those fiber ports are called. Look at that. Gigabit Ethernet 2/0/1. Ooh. So that's going to be really important that we notate fast Ethernet 2/0/1 because that's going to represent these guys over here, the copper interfaces. Then notate gigabit Ethernet 2/0/1 because the numbers are the same. The letter identifies it's one of these guys sitting over here, these SFP ports that I forgot to plug in. Oh my goodness. I moved offices. I moved all my equipment to a different location. I have to find those, where those SFPs are. Either way, it doesn't matter. We'll get them connected. We just need to know the numbers for now. I'm going to come back to the network diagram because this is actually fast Ethernet 2/0/1. This, because we couldn't tell just by looking at it, is fast Ethernet 2/0/2. This is gigabit 2/0/1. This is gigabit 2/0/2. Are you getting the idea here? I'm going to fill in all the correct names and make this all pretty when it's all said and done. This is just raw notes, but this is exactly what you have to do when you're in the real world. This is your paper napkin network diagram. You've got a sheet of paper that you're just drawing things out as you're getting them connected. Later on, you bring it back and you put it in Visio or Lucidchart or some other digital version of this. So let's move our console connection down to switch number 2 here. Snap, we're connected. Come back to the terminal and hit the enter key a few times. It looks the same because both of them are named switch right now. So I'll do a show IP interface brief. And actually, I should name these things as they go. Ooh, look at that. This is how I know it's a different switch. Notice it says fast Ethernet 1. So this must have been switch 1 in the stack at some point. And now it's tattooed its interfaces as 1/01, 1/0/2, and so on and so forth. I can see that the first 3 are up, which align with what I see physically plugged in right here. I know it's kind of tough to see with that little bundle right there, but there are 3 physical interfaces connected, 3 blinking lights, thus 3 statuses is up. Same thing as if I scroll to the bottom, I see gigabit 1/0/1, 1/0/2, which represents the SFP ports sitting over here that still need to be connected. So while I'm here, let's change the host name, and I'll do this for all of them. You go into global configuration mode, and I did this in one of the earlier videos in this skill. And this is where I type in host name AZ-SW0. This is 2 that I have right there. And I'm going to do a WR, which saves the configuration. Grab that console cable, move it 1 level up, hit the enter key a couple times. I'm on the next switch. Global configuration mode, host name AZ-SW01, enter. I'll do WR to save the configuration on there. Now let's move up to the last switch. I'm going to connect to console port is over here. this guy right here. This is switch number 3, but before I do that, let me jump over here and update the network diagram. I'm going to do this real quick because you already know how it's going. So you can see I'm going fast Ethernet 1/01, 1/0/3 to the WAP. Got the idea, right? And getting a little tight here. We're 1/0/2 for that gigabit Ethernet port right there. Good. Now we're plugged into the console port of this access switch. Hit the enter key a few times. I'm on switch. Get into global config mode and type in hostname AZ-SW03 is going to be its name. And let's do a show IP interface brief. There we go. This one is true to form. You can see fast Ethernet 0/1, 2, 3, and so forth. We've got the first 3 that are online. And then gigabit Ethernet 0/1, 0/2. That's going to represent the SFP ports right over here. Now, this uses the older style of SFP. Just about everything has become the LC connectors, but this 3550 uses the old ones. Over here are my fast Ethernet 0/1 through 3. So coming back to the diagram, these are all accurate. We just need a fast Ethernet in front of them. I'm going to do the other locations, the Nevada, the Florida, behind the scenes, and then I'll come back and update all of this in more of a formal way because obviously we don't want to stare at something that looks like that long term. That's just our chicken scratch. All right, there we go. We've got the labels properly in place, at least somewhat. I'm still planning to do some more cleanup on this diagram when it's all said and done, but at least it's not a bright red going across everything. You can see that we've got the right names on each one of the devices going right here. I've put the right interface name, fast Ethernet 2/0/1, and number, right? You can see that for each one of these. Jump on over to Nevada and Florida. And I've done the same thing for those locations. You can see that I've got Nevada, WP01 for the wireless access point, Switch 01 for Nevada. These labels were correct. They just needed the name in front of them, which over in those locations, everything is fast Ethernet versus being gigabit Ethernet over at the Arizona location. Oh man, I missed one right there. Fast Ethernet, fast Ethernet. Well, before the next nugget, when we get to the next skill actually, and put all these things together, I will have this diagram looking pristine. Right now, it's just filling it in with a lot of handwriting, which is a great start, but it needs to evolve to something more. So this has been an epic nugget. We have verified all the connections, powered all the devices, made sure they had blank configurations, verified all the ports were updated and now accurate. You can see there's many problems if you just assume you know what the interfaces are without knowing that mystical command, show IP interface brief. And we've set the host name of every single device in our entire network pod accurately. This is a great looking set of devices. And we've now ensured all CCNA lab devices are online, accessible, with correct interfaces identified. More to it than you thought, right? I hope this has been informative for you, and I'd like to thank you for viewing.